This lecture is intended to give you a brief overview of the endocrine system. And one of the first words that come to mind when we think about the endocrine system is hormones. And hormones do play a very important role in the endocrine system. They're important for things like muscle mass. We think about hormones when we think about mood, and they can affect mood. And we think about hormones when we think about growth and puberty. And so hormones have a wide diversity of functions, and we'll talk about those functions in the next couple of slides. Now, hormones can be classified into three different groups. There are protein hormones, which are very large molecules compared to the other two classes. The other two being steroid hormones and amino acid or fatty acid hormones. Now, protein hormones are about, like for instance, testosterone, even though this image doesn't show this very well, but testosterone is about 20 times smaller than insulin. So insulin is much larger than the molecule testosterone, even though in this image it doesn't look like it's 20 times smaller. That's just because of the sizes there are not adequately or properly represented. There in total are about 130 different hormones that can be classified into one of these three classes of hormones. And I give you three of them here as examples. Insulin falls into the protein hormone category. If you've heard of any hormone, that would be one you for sure have probably heard of. Steroid hormones like testosterone, again, probably one you've heard of before. And then thyroxine, a little bit less known to people, but this is a thyroid hormone that's important for thyroid function. We'll kind of talk about some of that going forward. Now that we've kind of linked the hormones and the endocrine system in our minds, let's talk about what the real function of the endocrine system is. Because it's not all about hormones, although, again, hormones are going to play a huge part in the endocrine system function. But what the endocrine system is it's a network of glands that control and regulate many of our functions. So this is really the control system for our bodies. That's one way to think about the endocrine system. And there's 5 main functions of the endocrine system shown right here. One thing they do is they regulate metabolism. Metabolism is the process by which the body takes one molecule and through several chemical reactions usually makes another molecule that's needed for the body. And so it can regulate that pathway, much like the thermostat regulates the temperature in your place of residence, in your home. Does the same thing. It senses the environment and makes changes to respond to that change in environment. For instance, if your house starts getting too warm, the thermostat senses it and turns on the air conditioner to cool it back down. And so something has to regulate that. It also maintains salt and water balance. That's very important for proper functioning of our bodies. It controls the responses to stress. So when we feel stress or in a stressful situation, a lot of that control and change in our body will occur, and that's in many ways regulated by the endocrine system. And we'll actually kind of follow a specific example using stress as our signal. And so we'll go through a specific pathway and how that works in just a few slides. It also regulates growth, development, reproduction. These are areas where a lot of us are, if we've heard things about the endocrine system or hormones, this is an area where we have connection to in terms of our ability to understand the hormones and understand how they affect us. And then the other thing that the endocrine system does is, well, we have to be able to make these hormones, and so one thing that this system does is actually make the hormones that we need that will actually be the regulators of these processes. Now, these hormones that help regulate our body's functions, or many of our body's functions, are made and stored in several different glands throughout the body. And so these images here show those locations, and in parentheses, a couple of examples of each of hormones that are made in those glands are shown. So it's not an exhaustive list of all the hormones and where they are, but just gives you a couple of examples for each of the different glands that make these hormones. And so a couple of them of importance are shown here. The pineal gland, the pituitary gland, and the hypothalamus are all in the brain, and so they help control many, many different things throughout the body. In the neck, you have the thyroid and parathyroid glands, which help regulate things like temperature and or hold your temperature constant, things like that. As an example, right below your sternum, in the middle of your sternum there, in the middle of your chest, is the thymus gland. That's a very complex and interesting one because it's how we regulate our immune system. When we think about the recent pandemic and COVID-19, wow, this thymus gland played a big role in that, in helping your body to recognize the virus and to be able to eliminate it. So your thymus plays an important role in that, but very complex, but very interesting nonetheless. Pancreas is one many of us know about because of the prevalence of diabetes in our culture, but that's the one that helps us regulate our sugar balance, for instance. The adrenal glands, we'll talk about the adrenal glands in the next few slides because we'll talk about stress. They help with that. And then we have reproductive organs that make several of the hormones that we need. The testicles, the ovary, and the placenta during pregnancy all make and produce hormones that we need to regulate these functions. So what we're going to do here in the next few slides is take one specific hormone and kind of talk about how that hormone works. And it'll give us, and we're going to kind of take some general principles from it, because the general principles of this really kind of play into about all hormones, or many of the hormones, and how they work. Now, yes, the target tissues will be a little bit different, and where they go and what effects they have. Yes, all that will be different. But there's just some generalities with hormones and how they work. So we're going to take adrenaline as our example. And adrenaline is made in the adrenal glands, which the adrenal glands are made or are located just on top of the kidneys almost. And so these are the adrenal glands. I'll circle one of them is right here. So I circled, there's an adrenal gland. There's one on the other side that you can see. And the thing it's connected to that kind of looks like a bean, that's your kidney. And so that's your kidney right below that. And these are located in your lower back. So if you reach around your lower back, on each side of your spine, one of these kidneys rests. So your spine would be running right down the middle here. So this would be your spine sitting right in there. You have one kidney on each side. And these sit below your rib cage, but above your waist. So that's kind of the general location of where your kidneys are. And again, the adrenal glands are sitting right on top of it. And this is, again, the adrenal glands are an endocrine, is part of the endocrine system, because they make adrenaline, and then they will release it when needed. When you encounter a stressful situation, your brain recognizes that, and it sends through the neurons. They stimulate the adrenal glands to release adrenaline into the bloodstream. And you can see in this image here at the bottom, you can see how the arteries are the network of arteries is very intense right around the kidneys and right around the adrenal gland. In fact, these are main arteries and veins that are passing right by the kidneys. And so the adrenaline hormone is very close to the bloodstream, and so adrenaline can quickly get into a main artery of the bloodstream and start to travel throughout the body. And what it will do is it'll travel throughout the body and go to the appropriate target tissues. And so we can take an example of a stressful situation as you're walking across the street. You don't notice a car coming or a bus coming, and all of a sudden the horn honks from the car that you didn't recognize or didn't see coming, and it honks really loud. You can imagine what changes you'll experience inside of you internally. A lot of those are caused or in response to adrenaline. Now this slide shows not so much the anatomical location of everything very well, but it shows sort of the response to the stimulation being the stress response. When adrenaline is released, when you're about ready to be hit by a bus or maybe attacked by a bear, you can think about it as another way. Maybe you're on a hike and you round the corner and there's a bear sitting there. A couple things our stress system, our epinephrine, adrenaline system does. And that is either we're going to stay and fight or we are going to run. One of the two things. Either way, our bodies are going to need energy and we're going to be exerting quite a bit of physical activity. And so the response to adrenaline in our system is to make proper adjustments internally so that we can handle all of that may be coming to us, all that energy that we're going to be exerting, all that we're going to be exerting in the situation. So let's walk through the couple of steps here, and then we'll make some common or we'll address the common generalities of this system. So if we start up in here, this is our brain. Our brain sees the bear, and so it goes, uh-oh, there's a problem, and it quickly sends a nerve that innervates from the brain to the spinal cord and eventually to our adrenal glands, and this happens almost spontaneously. This is our immediately. This happens very, very quickly, and then it shows catecholamines here, but don't worry, we can just think about that as being adrenaline, and the adrenaline is quickly dumped into the bloodstream, as we saw in the previous slide how closely networked that bloodstream is to the adrenal glands, at least major arteries, how closely they're in proximal location to major arteries. And that's dumped into the bloodstream, and of course the blood travels throughout the body, right, throughout every single tissue in the body. So now that you have adrenaline in the blood, all that adrenaline is going to go to all the different tissues of the body, and some of them are going to respond. And so what kind of things will happen? Well, one thing that will happen is adrenaline, as it goes through the heart will increase in rate. So you need increased blood supply because you're getting ready to do, you're going to exert some energy here. We need sources of energy, and so the liver can provide that in the form of sugar. So the liver can give sugar to all these tissues so your muscles can contract whether you're going to run or fight. You have now an energy source for that muscle contraction to occur, as an example. We don't want to have to go to the bathroom in these situations, so many times that system is shut down. Our blood pressure is increased many times because, well, our heart rate increased, so we're going to get a higher blood pressure as well, so that'll all be kind of related. And we're going to need to get more air in, more oxygen, and so therefore we're going to open up the airways a little bit more as well. And so you can see that the one hormone affects many, many tissues, but realize the goal of it is to be able to fight the bear or to run from the bear. So these are all coordinated in a way, even though you're like, wow, it seems like adrenaline does a lot of things. It doesn't really do a lot of things. It's trying to just get every organ system to do and work together to combat the changing environment that your body is seeing. So a couple things that are common between hormones from all this. Yes, the effects are not all the same. Not every hormone opens up the airways. Not every hormone causes an increase in heart rate. So the overall effect of the hormones are very, very different. The tissues that it targets, very, very different. Meaning, what I mean by tissues is, does it hit the lung tissue, brain tissue, liver, skeletal muscle, those kind of things. But there are some very commonalities between hormones. One is that something has to release the hormone. Something has to cause the hormone to be released from the adrenal gland. Nerve impulses are one way in which that can happen, and that's a major way it can happen. But that's one thing that has to happen. So something, when we're going to respond or regulate something in our body, so we have to have some way to release the hormone that's going to regulate it or release it. So something stimulates the hormone release, and then the hormone's got to get into the bloodstream. Hormones do not act typically where they're made. They act somewhere else. They're made in one location, and they usually travel to another location to have the overall effect. And the bloodstream is the way in which hormones are typically transported from one location to the other. And so you need something to cause the release of the hormone, and then the hormone must be released into the bloodstream, very common. And then there's some sort of regulation at the target tissue. So the hormone finds the tissues that it needs to target, and then it causes a change to those tissues. Again, an increase in heart rate, opening of the airways. That's the change, the regulation at the tissue. How does the hormone know which tissues are its target tissues or the one it's going to have an effect on? Well, we kind of go back. We've seen this before, where we've talked about a lock and a key. The key is our hormone, and the lock is a receptor. And receptors, or these locks, sit on the cells of the tissue that it's going to target. So, for instance, for adrenaline, which is also known as epinephrine, so that's the same. This is the key. There's the epinephrine molecule, and this is the lock. And what happens is the lock is present on the tissues that are affected. So, for instance, in our example that we've had so far, we saw that the heart increases its rate in response to adrenaline. So there is a receptor or a lock for the epinephrine molecule, where the epinephrine or adrenaline fits perfectly into that receptor. And when that happens, then you get the effect. So you can imagine that the lock, the same looking lock, is on heart tissue, causing the increase in heart rate. That's the effect. It's on lung tissues, because when the key hits that lock, the lungs, airways open up. But we didn't say anything about it being on things like the stomach so much. And so there's probably no lock on stomach tissue for adrenaline. And so therefore there's no effect, because there's no lock for the key to insert into and make a change. You know, when you put a key into a lock, the door opens, at least the lock to your home. But if you tried it in some other lock, it wouldn't work so well because it doesn't fit. So this lock and key is a perfect fit. So this lock is only specific for adrenaline. So wherever this lock, the adrenaline key or lock is located, the adrenaline fits in very nicely and a change happens. And so that's how the hormone knows where to go. It's because it finds things that it fits into and causes a change. All this down here is what happens, for what occurs for that change to happen. So this is all these things that happen on the inside of the cell. So this would be up here. Your bloodstream is up here. Your adrenaline is flowing through the blood. It finds a location where the lock, it attaches to it, and then once that happens, the key is essentially turned, and then all this stuff down here occurs to cause an effect inside the cell, i.e. an increase in heart rate, opening of the airways of the lungs, those kind of things. And so all the hormone is doing is just looking for the lock to bind onto, to insert itself into, and then changes happen in that tissue. So a different hormone would have a different lock to bind onto, and those locks for that different hormone might be on completely different tissues than the adrenaline lock is located. And so each hormone has its own locks, and they sit on the target tissues that they need for the response to adequately happen. Now, there are a lot of interesting endocrine disorders that go along with this endocrine system. And the main causes of a lot of these endocrine disorders are either there is an excess of hormone being made, you're making too much of something, so you're making too much adrenaline, so you're always in a more, your heart rate's always running a little bit higher, your airways are open more, those kind of things. And it's not a situation you want to be in all the time. Obviously, a deficiency of hormone could also cause an issue, so that's another one. And the third one is there's something wrong with the lock. And so if there's something wrong with the lock, and now the epinephrine cannot insert itself into that lock, even though the hormone's being made appropriately, the hormone's being released into the bloodstream appropriately, when it goes to try to find its lock, it does not fit in there right. Something's wrong. And so if it doesn't fit in there right, then all of this stuff on the inside of the cell doesn't happen. And so those are the three kind of main reasons why endocrine disorders occur. One thing that can also cause a problem and cause endocrine problems is nutrient excess or nutrient deficiencies can also cause problems. And so, for instance, iodine is important for the proper function of the thyroid hormones, and the thyroid gland, and so if you have too much of the iodine or too little of iodine, you can have problems. Things like hypothyroidism, goiters will occur. For those who are iodine deficient, so that could be a problem. It could also be a problem if you have a hypothyroidism something else, but one it could be is that there's a nutrient problem. Calcium and vitamin D are important for bone structure. This is very common in the U.S. Osteoporosis is where your bones get weaker and smaller, and so they're more likely to break. And that can happen because you don't have enough calcium and vitamin D in your diet. And so older, especially osteoporosis is common in women, and so older women can have problems with this, and so they tend to drink, or at least advised to drink milk to increase, because there's so much calcium in milk, that this helps increase the amount of calcium present, and that might strengthen bones. Or will help to strengthen bones. And so this is just, I think the point of this is, yes, sometimes we can have a problem with endocrine disorders for things like there's a gland problem, a hormone problem, whether it be too much of the hormone or too little of the hormone being made. But again, nutrients for these systems, for all these systems in our bodies to work, we need the full complement of nutrients so that for these functions to occur and metabolize properly. And so always we cannot ever discount the effect of nutrients and proper nutrition for these systems to work properly. So in some of these deficiencies and excess of nutrients, it's not the hormone problem, it's not the gland problem, and it's not the receptor problem, it's just you're just missing a nutrient. And so that's the problem. So here's a short list of some endocrine disorders and common endocrine disorders that occur. And shown here is listed by their gland and which gland is responsible. So we have some that are in the brain. Pituitary and hypothalamus are both in the brain. And so there's some disorders, endocrine disorders there. The adrenal gland is here and here. The adrenal cortex and adrenal medulla, you don't need to know those specifically, but these are just different layers of the adrenal gland. similar to how blood vessels have 3 different layers. We can think about it as having 3 different layers. The adrenal gland also has different layers, and so some things are in one layer and not in another layer. Parathyroid gland and thyroid gland are in the same location in your neck, so those two are there. And then the pancreas is the other one. And so what I'll do here is just kind of talk about one of them. And let's take an example of Cushing's syndrome, which is right here. And it's related to the adrenal gland. And just as you saw with adrenaline, notice one hormone can affect a lot of tissues. And so when you get disorders of the endocrine system, usually you're going to see effects on many parts of the body in many locations because these hormones affect many different tissues. And so if you're making too much of the hormone or making too little of the hormone, or there's a receptor problem, you're typically going to have effects in many different parts. And so there's a lot of different signs and symptoms from these. So Cushing's syndrome is basically due to an excess of a hormone known as cortisol. Now, why would someone have this excess? There's probably 2 main reasons for excess of hormones. One is a tumor. So when a tumor gets into a tissue, it can cause that tissue to start to overproduce whatever it makes. And so if it overproduces it, now you're in a situation where you're making too much of the hormone, and so that would be an excess. Sometimes medications can affect it. So if you're on a medication for a while, you might start making a certain medication for a while, you might start making too much of the hormone. But once you go off the medication, if it's something that you're just on temporarily, those symptoms should all subside. But the excess cortisol, that's at least just 2 reasons why you might have excess cortisol. And then what are the problems with that? What do we see? So what we typically see from that is shown here. Is some of the different things, and notice the wide ranging effects that it has. So it's not just again in one location, like you might think of melanoma. If you have a cancer of the skin, you got that melanoma. It's in one location. They can go in and surgically remove it as a potential treatment for it. But here you'll see that there's effects all over. Some of them are visible effects, and some of them are not. But things like the visible effects might be something like there are changes to your face. And so this down here is an example of a child that has that look. You get these increased fat pads on your near and on your back, and you can see that over here with this individual. You can see a couple different views of that. And so some of these are very outwardly visible to us. A third one is shown here, where you get these striations around the waist, and so you can see those there too. So these are just some of the manifestations of having excess cortisol. But the danger comes in sometimes is to things we cannot see, and that's why this becomes problematic. Osteoporosis can happen, where you start getting the weakening of the bone structure. Hypertension, so now you have high blood pressure, and we know that can lead to disease and heart disease. The enlarging of the heart, and it can lead to obesity. And so this is the problem with some of these disorders, is now you have these things that can lead to increased morbidity and increased mortality. Now, taking a couple of those disorders from the previous slide and kind of giving a little bit more information. For instance, thyroid diseases here shown in the first segment at the top here. You can get things like a goiter. Is usually a goiter is an enlarged gland, and so it looks like you have a big bump on your neck, because remember the thyroid's right around your esophagus, right there in the front of your neck. And so what happens there is if you have hypothyroidism, your body responds by trying to make more, or enlarge the thyroid so they can produce more, because hypo means you're not making enough. And so it thinks that if I make more thyroid tissue, I'll be able to compensate for the low amount that I'm able to make with the thyroid as it is. Bigger thyroid, the hope is more normal thyroid function. And so you'll get a goiter that will form. Your body's compensating for the low amounts of thyroid. So that can happen. But there's a couple different endocrine disorders associated with the thyroid gland here you may have heard of before. Graves' disease has some is relatively common effect of the thyroid gland disorder, where you're actually making too much thyroid hormone. So it's hyper, too much thyroid hormone, as opposed to hypo. Hashimoto's disease is is probably the most common form of hypothyroidism. The pituitary gland regulates growth, and so GH in this stands for growth hormone. And so you have times when you have not enough growth hormone being made as a child, and too much. And so this causes dwarfism or gigantism, depending on whether you're getting too much or too little of the hormone as a child. And then this can also be seen as an adult as well. And one example of this is a well-known wrestler back in the 1980s era, who had gigantism. And you can see here from the picture in the middle, here, you can see the difference in size between Andre the Giant, the wrestler, and some of the people standing nearby him. So he was a pro wrestler for many years. He was a very large individual, 7'4", 520 pounds. You can see him here next to this big car, and that's a big car. You can see how big he is. And so one of the problems with gigantism is usually the life expectancy for someone with that is not very long. And you can see not uncommon to die at a young age, and so he died at 46 years old.